So where exactly do they stop? I know we still remember where we stopped. Inertia, okay. So let me see. I think that was the conclusion of K-mean what? Clustering. Remember that the main topic is still data modeling, right? And we said there are three common methods. Or let's say we are looking at the common method for common method which are used in data modeling in machine learning. The first one is data clustering, and then we have under data clustering we have about 3 to 4 methods. The first one is k-mean clustering, and then the second one is hierarchical, and then we have the DB scan, right? Okay, now that inertia was a technique which we use to determine the number of what? Clusters. So that's actually brought us to the end of. So I just want to know if I've gotten to where we stop. We've done all this, right? Um, Creating k-mean model for 3. This was the assignment I give, right? And then we also solve the assignments. So this is the inertia. Now we are looking at the second data clustering technique, which is hierarchical clustering. Hierarchical clustering. So how do we define hierarchical clustering? Now, I want to take us back for a second. Remember that the genesis of this topic tells us that in machine learning under unsupervised technique, we have a way of segmenting or grouping, right? Yes. Our data value based on a criteria. And all this while we have been using distance what? Based criteria. And I also cited some of the use cases in real world that you can have different branches, or you can have an inventory data set, and you want to cluster. That is what you want to group your customer in different classes. So you can use the behavior of their purchase to cluster them. You can use other factor. So that is the idea. We did establish that one of the direct benefits of clustering data is to enable an organization to make certain informed what decision, particularly when it comes to maybe running ads or creating awareness. So they will not be able to know which set of what customers they are to, or audience they are to target most. So all this we are learning, we are learning different techniques, different library, different what function. But in real world, we are learning different ways insights can be derived from data sets that can improve decision making. So hierarchical clustering is a clustering technique that creates clusters by grouping similar data points together. So the emphasis here, or the criteria for the clustering, is what? Is similar data points. Similar data points. Unlike the K-mean concepts. The K-mean concept, we're using what? Distance-based, right? How one data value is distance from the other. Now, I want us to look at the diagram on the screen because I back that definition with this diagram so that we understand exactly what we are discussing. So these are like different what? Data points. So we have data at point P, we have point 2, we have point 3, we have point 1, and then we have point 5 and point 6. So if we want to group them, we want to cluster them, we are saying that we have to look at what? The points. And we're also applying distance also. So distance is also a major factor because the reason why you easily group all these in one cluster, because if you look at what? The distance between these various what? Data points, they can be in one cluster. And then we have the P5 and the P6 that can also be in another cluster. Now, this is where you have already deployed your technique to visualize it. So what we are seeing here is these are the two clusters. The one, I think for me to be able to navigate effectively, I have to go back to the normal slide so that you can be seeing what I am touching. So like I was saying, as you can see here, this is where this is the graph that is representing this particular cluster. This is the graph. You can see that this P4 is distance from what? The other two what? Cluster based on its location. Now, the reason why we easily associated it with what? P1, P2, P3, because if you calculate the distance from here to here and here to here, it is better you link it up with what? With this set of what? Data points. So as you can see the way it's connected to them. So this diagram, we should be able to know how to interpret it because our endpoint visualization is going to come up something like this. You know, at the end of the day, we are expected to write our observation, right? That is what the company needs, not all this. So if you look at this observation here, you will see that what, if you look at the reaction here, you know that this P4 is more associated with what? P1, P2, what? P3. That is why this line is showing that what is connected. It can easily cluster in that group compared to what? This is totally far from what? Cluster what? P5 and P6. So there are a lot of insights we need to establish before we can understand what we are doing. So let's quickly look at this hierarchical clustering. So like I said, hierarchical clustering is clustering technique that creates clusters by grouping similar data points. But here we are looking at how it works. How does it work? So number one, within a scatter plot, find the two closest points. So we are using a kind of practical scenario to break it down. Now, if we have seen, I believe all of us have seen scatter plot before. That's why I told her that most time in data science or machine learning, we use scatter plots to communicate. Or like when we were in data analysis, we were basically using a pie chart and what? Bar chart. But those ones are not really that effective when it comes to data interpretation in data science or machine learning. So within a scatter plot, find two closest. So this first option, how it works, it means that it uses what? Distance, right? The distance between your data points. Then the second option says find the next what? Two closest what? Point or clusters and group them to clusters. So if we can see picture that first diagram, you will agree that what? That diagram has explained some of the things that I'm highlighting here as regard to how it works. Then number three, you have to keep repeating until like that four that was, that was not initially in cluster one, P1, P2, P3. By the time you repeat the entire process, at a point you will say it's navigating towards what? One direction, or finally fall into one of the known cluster. So that is why it is recommended that you repeat the concept. You repeat it until that very one you are trying to group fall in a known cluster. So this process is visualized using a tree diagram. That is the picture that showed us now. Tree diagram called dendrogram. Dendrogram, which shows the hierarchical relationship between cluster. So that is how you are going to visualize it. So we are going to use a function called what? Dendrogram to what? To visualize it. And like I've explained, it will establish relationship. At the end of the day, based on the relationship it must have established, it will not enable you to easily write your observation, because then you need to see the relationship. Okay, can I proceed?
Yes.
All right, so the next here, we are still trying to illustrate it. So we have various steps we are expected to follow for us to be able to achieve clustering our data points using the hierarchical technique. The first step is what? You find the two closest points and group them into what? A cluster. That should always be the first step. So if you look at it here, we just identified 2 points here, 1 and 2 first, right? Now we'll now start looking at how we can group them. Now, there are many calculation or many logic that can be used to know the first 2 points. You can rule a straight line. Where you rule a straight line, it is called Euclidean distance. That is, you are using a straight line to determine the relationship between what? One point and another point, or to measure the distance between one data point to another. So when you are using that logic, it is called Euclidean distance. So this is when you are using a straight line, like I just explained, to measure distance between data points. Can I proceed? Okay, now this is another method. So where you can see how you are trying to establish the distance between two data points. So this is just like a block method, and it is called what? Manhattan distance. So all these terms, we need to be familiar with them. So you can be asked, what is Manhattan distance? Is a logic used to identify what? The distance between two data points where you are using a block form. So now I think there's a place I put it to say how many blocks do you have to work to get to what? One data point. So you go like this, you come like this, which is represented with the shape of that Manhattan distance. So in data science, I try to emphasize again, in data science, I don't know if it is tiny that you may not be able to see it. So in data science, should I increase it? Are you seeing this right up? Okay, so let me go back to that view. I hope you should be able to. Hold on. Okay, I think you can see it better now, right? So in data science, Manhattan distance, also called what? Taxicab distance, or L1 distance, that is shape of an L, is a way to measure the distance between 2 points in a grid-like space by summing the absolute differences of their coordinates. So why the name Manhattan? Just to give us an history how it came about. Imagine you are in Manhattan, New York. The streets are in grid. You can move diagonally. You must move. Sorry, you cannot move diagonally. You must move along the streets. So this is like a structure of a city where maybe based on the way it's structured, you cannot move that. We have to, go by certain axes before you can connect to. So that is where they derive the name Manhattan from. That is that kind of movement. Eh?
The city in New York, where the position of the city
exactly
is blocks, the high-rising blocks are such that the grid, when you look at it from the top view, it's a block in a grid form.
Okay.
So taxis, you can't. It's not like our streets here where you can easily bend.
You have to follow
the this way,
right this way,
or left this way.
Okay. One day we will get there so that we'll see all this. Me and online. Me, I don't want to go online. I want to go real.
I know you just from.
Well, the way you are breaking, as if you have been there. Okay.
It's mostly from.
All right. So now, let's look at now you can see this is another method. I want us to take note of some key terms. Remember, there was a place where I mentioned what? Euclidean, right? And then what? Followed by what? Manhattan. Now we are seeing what? Cosine what? Distance. Or, yes, cosine. So all these are what? How will you refer to all these three terms that we have used so far? They are method of what? Good, exactly. So, and you can see the diagram representing it. So at the end of the day, it's not less for you to know which one is better. So just to explain further, so all of them should talk about what? Closest, which means that what? We are actually clustering these data points based on what? The distance between them. So it is not left for us to know which of the technique we want to use to measure the distance.
So note, instead of looking at distance between 2 points, for this particular one, I think this one is not distance based. It's about what? Angle. So it is not left for you. So like I noted here, instead of looking at distance between 2 points, we look at what? The angle between them. And that is what is represented with the diagram. So we are still on that step 1. Now, what are our observations here? Finding the closest points and grouping them into clusters. You can see that P5 and P6 are what? Closer. Therefore, in one cluster. Now, if you look at this one now, this is step 2 now. Step 2. Because step 1 is that what? Try as much as possible to establish what? 2 points first before you start looking at, okay, other ones. Which one can go into one? Which one can go into what? Other. So step 2, find the next 2 closest. After you have completed the first step, find the next 2 closest points, clusters, and group them together. Now, the diagram also have defined it. The next 2, this time around now, we are looking at what? P2 and what? P3, right? And P5 and P6. Now, we have P1 and P4 left. So the question is that what? Now that you have identified 2 different closest points now, the remaining ones, what factor will determine whether, because at the end of the day, they must find a group. They must find a group. So it's not left for you to know, okay, you start calculating the mean and the average later. Sometimes use variance. We are going to bring variance to know, okay, whether this should go to what? P5 and P6 cluster or P1. But when looking at this, I'm very sure that it's possible that the P2 and the P3, right, might end up taking P1. And if we possible say the P4. So observation here, P2 and P3 in one cluster, P5 and P6, another cluster. Then P1 and P1 is another cluster, P4. So how many clusters do we have here now? 4. So at the end of the day, as we repeat the process, the number of clusters will keep reducing. That is what we highlighted at the beginning, that you have to keep repeating it until you start, you keep having the same thing. That is where you can stop that. Oh, this is the final cluster I can have. Step 3, which just back up what I just said now. Repeat the process until all points are part of the same cluster. That is when you can stop. So that is what has happened here. So when you repeat it one time, you see that the P2 and P3 have taken P1. Then when you now repeat again, you might have P4 joining. So observation here, you will notice P1 is closer to P2 and P3 compared to P5 and P6. Therefore, can be put in one cluster. So now how do we put them in one cluster? You can see it now. This is where I show the diagram. So what is shorter? That is what you now use now, where it remains only one. Sorry, which is which is shorter, to know where P4 should go into. So we have to now examine the distance. So how do you define distance between cluster? We have single linkage. You are going to see that is a function. So like I said, you need a very strong background. All this theory, you need to understand them before we go to the practical. If not, the whole thing will just look like abstract. So that linkage, you see where we'll be using a function to get to calculate the closest. Now, there's a note I have here where I said, now, here we are considering which cluster can P4 be allocated while comparing the distance. That is like our thinking pattern at the moment. We are thinking now that the factor is which is shorter. So at the end of the day, step 3, we repeat the process, For you to achieve that, you have to repeat the what? The process. And then when you repeat the process, once it's complete, what you are going to get, or here, we are using the distance between P4 to P2 and P6. So look at another logic that you can use. You look at the line now. You can say, okay, if you are not sure of the distance, you can say, okay, between P4 to what? P2. Initially, probably you were calculating what? P4 and P3, right? So another factor, you can say, okay, all the way from P4 to P2, then all the way from P4 to what? To P6. We tell you whether the distance is equal. So how do you define the distance between cluster? The same thing. So here we are trying to exploit options from different. Yeah, this complete leakage now. Yeah, single. Because look at the single, the difference between, look at the two straight line. The P4 is going to 3 in this case. But going to 4 is complete because it has gone through what? The ones that are exactly. So now, the next one is here, we are now plotting it to all the value. You know, the other time we did not consider what? P1. That's the difference. But here now we are linking it to all the points before we come to conclusion. And it's called what? Average linkage. So we're going to use average linkage. That is what you will sum them up. Then you will now divide by the number of what? Data points to know which one should be associated with. Are you following? So which means that logically, what we are saying is that if I want to calculate the distance based on what? The way it's connected to what? P5 and what? P6, I am going to add them together, divide by 2. Right? The value I will get will tell me if it's lower than what? The value I will get when I add what? These 3 points, divide by what? 3. That is the average. That's what's called what? Average linkage. That is what? All pairs. You are comparing it to all the what? The points. So here, a lot of average calculation will be involved. You are going to be doing a lot of calculation that will involve what? Average. Now, the next one is what? You repeat the process. We have what? Word. All these are what we are going to see in the function as attributes. So how do you define distance between clusters? Remember that we're here. We have 4 of them, right? I'm like recapping all of them at once. That we have, how do you define distance between clusters when you are using hierarchical what? Technique. Number 1 is what? You can compare with what? Single what? Linkage. Complete what? Linkage. And average what? Linkage. And then what? Word. And they all have under single linkage. Your priority is what? Closest. Are you following? Then under complete linkage, your priority is what? Farthest. That's what? Which one is what? Farther than the other one. Then average, you are what? Connected to what? All pairs. And then words method, you are using variance. That is, you are going to square the differences at the end of the day. Now, how do you define distance between? So this one is still the same thing, but here we have a different connection, which is different from what we are seeing there. They were not together. But here, the same item, the same method, but the connection is different. So here now we are trying to look at it critically. So you shaded it and know at the end of the day, which of them should take it. So now you can see that both has what? Both has included what? P4. So both of them are trying to what? To take what? The P4. So now, here, I think it's the same linkage, but here, question to ask. Which variant changed the lists? Because from the initial diagram, both of them, that's what the P4 now what? Belong to both of them. Both of them can be, can cluster it. But there will be a factor you will use to disconnect it from one. It must belong to one at the end of the day. So here we are now saying, okay, since we have deployed the average, now let's use what? The variance change. The changes between what? The variance. So here, finally, P4, like we envisaged from the beginning, you know, we have already said that at the end of the day, P4, we end up what? Going into what? The P1, P2, P3 cluster. So the display of all this is for you to know the processes that, the kind of calculation that they function. All this, you are not going to be calculating the humanly. Why I am taking us through all this is for you to know that machine learning is the one that's going to do everything with what? Python library and function. But this is what, these are the factors, these are the bases we'll be using. Well, you are not going to see it. You just run your code, you just get the what? The cluster. So everything we are discussing is to give you a picture. If you have to do it manually, that is what we'll have been doing. So you can see how the machine learning has really made the entire process easier. Now, this is the code. Remember, I talked about visualization. Now, and when I was discussing that visualization, I mentioned what? A function that will be used, right? And the function is still mentioned, which was dedogram. Function within the SciPy library. So we're going to bring in another library here. The other time when we use k-mean, what do we use? sklen, right?
Yeah.
Now we are bringing another library. So these are the core Python library that you are exposed to as a data scientist or machine learner that data analyst does not. Because when we learn data analysis with Python, we did not mention some of these keywords or core library. The one we use most here were just pandas, numpy. So what will this dendrogram help us to do is for you to visualize your hierarchical what? Clustering clusters. So I want us to code this, write it, or maybe you code first, but yes, just write it first. We will go through them one after the other until we are able to get it. Well, let me give us some time to write the code first before we start explaining them the way we did the other time. Now, let's go to our notebook and start relating this code. So the first thing we are going to do is to call in our data or just to view our data again. So let me just exit from here. So hierarchical model of clustering. Technique. Like I said, let's call the data or data sets. With .head just to view probably the first 5.
Okay, is it the same data that you have there?
I just ran mine thing that it's not the same thing as
It's not the same thing, right?
This one is the password to the old TV shows, video games. This one is entertainment. Data set entertainment.
Oh. This one, I think
But this one is serious.
Then the data, where do we have that one? Where do we have exactly this one?
Which one? The
one I just called now. I thought we have it here now. I don't have it here. Okay, we have it in the main sheet, not here. Because I created another one that day now, which was what was the name I used? No, we created another data words. We created another one. Yes. No, when we're about answering this that assignment, that where we use this array.
That's the one you just said now.
So where did I have? I'm looking for where I have that data. So that is the sheet I want to.
Data underscore sign.
Data underscore sign. This one, right?
No. The one over here.
Here.
Yeah.
Let me tell you. This one. You know, I got this folder from Miss Gwinnett. So there's this. I think she was even the one that identified the file we are working on. It's like it's this one. Right. Like something like this.
What is that?
Not this one.
The one that has the performance, books, TV shows.
There was a notebook. There's a notebook that we're working on here. Where we homework, have we? No. This one. Where?
It's our homework. The one I do here.
This one.
No. I don't know.
This one. Yeah. I thought it's part of the one I just opened.
I think it should be.
Is it here? Did you save any data as a data? No. I know there is a place where data. I was working with. Oh, wait, let me go back. Let me see if probably I must have used another name too. It can't be here because that particular data is that particular data. This is it now. This is it here now. That is what we use. Wait. This is the one I want to use.
For the name you use for it.
Yeah, that is what I'm looking for now.
So you see that it
is this one now? This is it now.
Yes.
I use it as data.
Yeah. But the thing is that
it's like I've already
you've overridden it with the data. With this assignment.
Hey, Jesus. Okay, no one. Let me check something.
This for this series, like this another thing. CE on that data. Also the different.
It's an expensive mistake.
So you're saying we should run it with this particular.
Yes. So that we have this one I'm looking for. But let me see if I can use that one. I just want to see. I should copy and paste which one.
Okay, so what will happen is that just that my interpretation will be different. Let me work with this because I already have an interpretation, but because going through this process now, we just waste our time unnecessarily. So since this data is perfect, all numbers, all values are what? Numeric, right? So we can, let's use it. Let me use this one to continue the process. But if you have it, fine. So now, this was the code you wrote, right? I think you have implemented even this. Am I correct? This is the code you wrote now. Is it not the same?
Yeah.
I know I have it somewhere. Let me see if I can go and get it. If I can't get it, it means okay, so
Want to look for it.
to avoid typing, I know I have it somewhere. I have it in one. I wanted to just copy it so that, okay, let me just, let me go through it all over. Don't waste time. So now, visualization, faster with this. Visualize the cluster with the program. So start with importing the library. Sci dot cluster dot I hierarchical import linkage comma then program import matplotlib dot pyplot as plt. So let me run this and see. No module name cipher.cluster. Why? My spelling not correct? Dot hierarchical. Okay. Hierarchy. Okay. Linkage. So here we are creating an object matrix is equals to linkage function. So this is what we calculate the distance now.
Now, the name of our data sets is this. And remember, we mentioned how many methods the other time? How many methods? You still remember where we mentioned the word? We have other method there. That is a single, complete. So you know which one we are using. And what is the criteria for using word? When you are using word, what does that mean? Then I'll say then ground. Info underscore info equals to then program then program function linkage we are supplying the object which is this. So let me even see if I can easily get it here. Okay. So let me execute this to see if that is taken first. Yeah. So the other code are just for explanation, like the y-axis, x-axis. So this is the main code. And then we have our, so how do we interpret it? How many clusters do you have here?
Though I have not finished writing the code because if I go to I still have this, but I don't want to waste my time writing this because this one they are just for labeling the graph. So these are the, so we can move to the next step. So here we want to now know the individual because just like we just ran the whole code. Now we want to know what is doing what. We want to start explaining each of those code. So I'm starting with the first line, which is what? Linkage, where we supply our data and then define the method. So this is the main function performing the calculation behind the scene. Because from the first part of the class where I was working on through those visualization, those images visualization, we explain what linkage and the dead program are responsible for. So that is what, now you can see that if you run only this line, you will get array of this value. So this is how it clustered. These are the values in the data set, all this you are seeing. These are the values in data sets. So I'm going to talk about them briefly to explain what is this cluster representing. What is this cluster representing? So we are going to interpret that. But let me quickly go and run just that line of code first. Can I move? Okay, so now, like I said, we want to explain the code and know the code that play the major role in visualizing this data. So let me just name it explanation of the key function in the then program outputs. So the first one is this. So I will just copy it. I think there's a place where I have run it. So let me just copy and paste to save our time. So we want to find out what impact this one actually made.
Is it how you want to have outputted?
Because
Yes, we have not called it now. We have to call it. I know it's a variable now. It's a variable. So if you want to see the value, we have to call it so you can. Yes. Yes. So you can see different clustered, different value. This data is much compared to what. So there might be some differences in the slide though, because we are using different data. So this is the array of the clusters. That is what this is telling you. And remember, we said that what the linkage is the one that establishes what the distance, how one data point is what far from the other. So how many clusters do we have here? 1, 2, 3, 4, 5 clusters. So if you come to this place now, how can you identify the 5 clusters? Because now that you have viewed the value, now you want to know why you have this, why you have this. 1, 2, 3, 4, 5. Do you understand it now? So the importance of running this code is for you to conform it with what? This. In case you are having issue. These are not 2 clusters. So these are clusters that their values are familiar. That is the reason why you have them in one column. But this one, the values are not familiar at all. That is why it's colored them differently. But you will have 1, 2, 3, 4, 5, which this array of value is telling us. 1, 2, 3, 4, 5. It's like we're having 4. Is it 4? Is it 4? Okay, let's say 1, 2, 3, right? Yeah. Which one?
It's the bigger one. The bigger one. The one.
Hey, this is 1, right? 2, 3, 4.
Yes.
Good. All right. So that means this one is just like a square bracket that is separating the value on the rows. All right. So there is need for you to always run this to know, to just to confirm. Because what we are doing now is that we are trying to explain the dead program output. Now, let's do the shape. I want to know how many. We already know this concept from the beginning. When you run the shape on a data, what does that mean? You want to know the width and the what? The height. Or you want to know the number of what? Columns and the number of rows. So the 4 will inform us that what? We have how many clusters? 4, right? Why it will also tell us the row. So all I will do is just to concatenate the dot shape. So I will just copy the same function and say dot shape. So if I run it, that will tell me, then I have to run, yes, I have to run the variable again before I can get the desired value. So here I have 73 rows. That is what? There are 73 what? Record of values that are clustered in what? That are in 4 clusters. That is what this is indirectly telling us. Okay, so the next one is, I think this is the same, but here I try to point out some observation as a way of explaining why we have or what each of these columns are or clusters are representing. How do we know which one is this one, which one is that one? Now, the third column represents what? The distance between the first 2 clusters of the data point that are getting merged. That in this case now, let's look at the third column, which is this. Just like the way, just take your mind to where we're looking for the P4. The P4, when we're looking for where the P4 will be into. That means that P4 was in between. Hope you know that.
Yeah.
That P4 was in between the P5 and what? P6 and what? P1, 2, 3. So that is what we are trying to explain here. So what you have at the middle now, as the third column here now, represents the distance between the first 2 clusters of the data point that are getting meshed. Then another observation here, the fourth column represents the number of data points that are within the newly formed what? Cluster. That is what it's defined.
Does this interpretation apply to the data?
No, we have to go back there now.
Because
It's a different data. This is the other one that we're looking for. So if we come back here now, we have to have a different interpretation. So the question now is that it's still the same thing if you look at it, because this is the third one, right? This is the third one, which is still aligned, because this third one is showing the distance between the first two clusters and the last cluster, which is this one. That is what this is indicating. It means that this and this can be in one cluster. How do I know? Based on the distance. So this one is the one, the third one is the one separating this. When you look at the value range, you can see it now, 2, 0. So you can see that you can see that they are not in the same category. I don't know if you are with me.
yeah.
They are not, the range of numbers are not the same. So that's why it's easy for us to say that this one is a standalone. Because the value of this one, they are not here, they are not here. So which means that these two, they are two different, look at their value, they are almost the same thing. You can see it. So they are actually in one range, one cluster. So logically, when you have it like this, the third one, if you have like 5 clusters now, then the measuring distance will not shift from being the third one. You have 6, it will also change. But you should always compare the values. The value will tell you based on that closeness that we are using as a factor. If the values we have here now, maybe they are close to this. Definitely, if they are close to this will be here. Which are the individual? Yeah, these are the data points. Good. Data points, yes. Yeah, it will join. But yes, it will eventually join. But what we are saying at the moment, now looking at these arrays of data points now, for it to come at the center, it's just like it's the one separating. But apart from that, it's not just the one, because we can say even, we say okay, 2 here, right? But there's a factor we are looking at here. Look at the range of values you are getting. It shows that this one, they are in one cluster, or they can be. Because we said that there is no perfect from the last class. It depends on when you run it repeatedly, and at a point the values are not changing. You know that all of them have actually belong to cluster. So nothing can happen. So logically, what we are saying is that this very center, the third one, is the one determining the distance between these first two and this one. But it is not less for us to continue running until we now know whether this can easily go in here or go in here. But as far as I'm concerned, I've already know where it's going to. It will end up coming here. Because when you look at the differences in number, you know that this one is closer. So which means that it can easily enter here. So this is just like we are trying to logically picture what is the dendrogram representing. So now going back to our slide, okay, let me go. Okay, you want to write? No, you can still write it because it's tally with the data. No, it's tally. We can write it. Can I move? All right, so now I think I have also written it somewhere. Let me go there and copy. So this is what we want to run and see what exactly this is doing. So I will just take it. So what error is this? Dendrogram. Is it the same error? Is it the same error? No. Okay, so just take the interpretation. What is doing there? This is taking the array of the data
and putting it in the dendrogram. That is what plotted the graph. So I believe that is the reason why it's not outputting, because it has outputted the graph. And before it can output valid image, we have to run it together with the function.
No.
Run.
Eh?
It brought out the graph.
Yes, brought out the graph.
But how come our own did not?
Without the
Okay, let me see.
label.
This is what you did, Abi. Okay, let me run everything again. If it's, are you sure it's the same thing, Mr.
Yes, sir.
Because it's supposed to bring out the result, because that is actually what is plotting the graph. That is what is plotting the graph, because those values that we saw, those array, we will take them and put them into this dendrogram. Maybe it could be our own.
It says what the error it must contain something.
Did you have that error before?
No. I don't have it straight.
The same code that we have here now.
Yes.
So maybe it could be version issue. Ms. Quinette, have you run your own again, all the cell again? Let's see. Okay, so the interpretation has even explained what it does. So let's move on.
Sorry, let me go.
This one.
Okay, so now let's look at
So this can no longer go because it's not the same data, but we can use the idea of it. So you can see like here now, it's talking about what? You will notice that we now have just what? 2 clusters in this one, but it's not the same data we are working with now. Now we are going to update something in order to, we are going to add an attribute called color what? Threshold 10. Now, is that first code we are going to modify? Now, the essence of it is to set distance value, that what? No value should go beyond certain what? Distance, so that you can clearly see your clusters. So the essence of this is where you are struggling with knowing the clusters, so you can set a distance limit. That is where you bring the color threshold. So once you have written it, we can now go and modify our code to see the impact is going to make in the graph. All right, so let's go and update it. Are you still writing?
Yes.
Okay. Can I move?
Yes.
Okay. So let me go back to the code. Or what you can just do is to copy that code and paste it so that you can still retain the other one if you want. Just copy and paste and add. You can see the way it sets. It makes it look more real now. Like we said, any color. So you have a different appearance now. You now have like individual colors.
You go over video.
As you go up,
Okay.
How we go?
so this is the explanation of the outcome of the threshold. Now we have 3 clusters. But now, initially, you can see that after applying this, initially we were grouping all this as one word. That is, even within this, you can have what? Sub clusters. So I can have 1, 2, 3, 4, 5, 6, based on the color differences. That is what we are trying to apply here. Now, where are we now? Okay, here. So now we are going to look at another way of achieving. That was using a dendrogram. Now you can also use agglomerative clustering in Python. All these are different methods. We are still under hierarchical. So under hierarchical now we have what? Agglomerative and what? Dendrogram of visualizing. So looking at this one now, another option. So in case, for me, I prefer this option to an extent because it's very simple. It does not require writing too much of codes. So the agglomerative clustering function within sklearn, the other one we got it from where? SciPy, right? SciPy. We got it from that dendrogram is a function under what? SciPy function. Sorry, SciPy library. But this one we are getting it from where? sklearn, which is part of the what we use for clustering. Now, but you can see some attributes that are already known. You can see linkage here. Even in this library now, we are seeing some attributes. So seeing that linkage, you already know what it represents. That is, it's still measuring data points based on what? The distance, the closest. So we have written now, this is the first part of it. Okay, I zoom out that and let me zoom in so that so you can see that most of those attributes that we mentioned in dendrogram are also mentioned here, like other what distance method. Now you have written that. Let's go to the next slide. So the next slide, I'm still trying to explain. So here we are importing the library, the function clustering from the sklearn, which is this line. And then here we are fitting, we are transforming. Remember, we have used this fit function before, which means transformation. That is what you are converting, you are clustering. And then here we have used label before. Here you are viewing the number of what? Clusters. Now here, so let's go to the notebook now and start implementing them one after the other. So we'll start from this. We are going to import sklearn because it's the library that is offering us the agglomerative function. So let's quickly go there, and so here I try to explain, which is self-explanatory. Here we are getting the library. Here we are saving the library inside an object, and we are specifying three to how many cluster? Three what? Cluster. And then here we are what? Concatenating the transforming or transformation function. We are transforming the data with the dot fit function. And then here you run it. So this is what you get. So this means that your entire data object or values have been clustered into what? Three. So let's quickly go into that. Let's run this set of code before I proceed. Have you executed?
Yes.
So let me also go and can be on the same page.
Fourth line.
Right. Okay. Like I said, I will start by importing sklearn. Let me just go straight to the function since I've explained with slide. Sklearn dot cluster. Import. Remember, is case sensitive. Numerative. Where is the error? Capital letter C here. All right, so that's accepted. Let's go to the next one. Let's save it as an object, egg equals to, call the function. and then specify how many cluster. Now I will now fit the data to transform, concatenate it with the fit for transformation, and then supply the name of your data, which is this. So perfect. So now the next thing is for us to view the array of the clusters, the three of them, using the label. Hope you still remember this. Let's use label to view it. So simply call the data object and then labels underscore for us to see the cluster, because as it is here now, the data value have been clustered into three, but we are not seeing them. So we need to use label to view them. So I will just simply say data dot label underscore to view the array. Object has no attributes, labels. Object has no attribute, labels. What? Any mistake? Okay, sorry. Not data. I'm using the object, like, which is what? AGG. Yes. It knows what it's doing. So how many clusters do we have here? 3, just as we specified. So that place where you have 3, you can change it to 4 and run it again. Let's see what you have, whether you now have 4 clusters. Just try it temporarily. Let's see. Let's say we change here to 4, and then we execute this, and then come here, execute this, and then come here, execute this. So you can see that we now have what? 3 what? Cluster. Sorry, 4. So let's go back to 3. Remember, there was an advice I gave to us that what the more cluster, the more it will be difficult for interpretation. That was the reason why we introduced the heat map, where the clusters are much. So you rather consider that option. Then here, so you can see the way it's updating this automatically. Now, the next thing we are going to do now is, let's see how I can cover this. Now, we want to view the data points. We want to view the data points. So we are going to import a library, which is called collection. So we say from collection, import counter. So this is to enable us to view the data points that it clustered into the 3 clusters. Can I move? Yes, writing.
Right.
Okay. So to view the data point, let's quickly look at. We have to import, so I'll say from collection import counter. Run it, saying counter from collection cannot import what? Name counter. Capital letter C. Okay. No, the collection is that now let's use, now this collection is a library also. You understand? Inside it, you want to access a function. The function you want to access is counter. So that is why we first of all brought it in. So we now say counter, since we have the library counter, we supply the cluster object and then dot labels underscore. So this should be able to help us to view the capital letter also. Okay. So you can see my data point here is different based on the data sets I was using to create the slide. Remember? So you can see that the points are different. So the points here, we have 0. Yeah. We have what? These are different points that it established. When we started, I said, identify two points, right? Then before you start considering which of the elements or which of the good. So these are the points that it established in order to get this data clustered in 3 clusters. So the next thing is we are looking at what? Mapping. Now we want to visualize it now. Remember that this is just like a heat map, but it's not heat map. This is actually a visualization for us to be able to see it clearly. So we are using cluster map in Python. And we are getting this function from another library called what? Seaborn. Seaborn, like we know before now, is a visualization what? Library, right? Seaborn. So we are getting this from Seaborn. Add a heat map on top of the then program. So you can see that if you look at it very well, I don't know if you can see it the way I'm saying it. The dendrogram is at the back. Abi, you are seeing that heat map is on top of it. That is exactly what. So while we are having part of it, because we can actually identify the cluster with the dendrogram and also still use what? The cluster map. So you have these two options to be stacked so that you can probably understand what is happening. So which helps visually interpret each cluster. So the essence of bringing this because of the interpretation. Because if I ask us now, using this agglomerative technique now, with this data point now, how will you be able to write the observation? It will be difficult. That is why you have to bring this concept, because we are getting to where we will conclude with our interpretation. To bold it, Abby? Yeah.
Okay. Assuming also that we've imported Simon in this particular.
Yeah, if you have not imported SIBO, you have to go and import it. I think we must have used it somewhere now. No, I don't think we use it.
Yes.
But we have a matplotlib already now.
We have that one. We have matplotlib, so. Are you still on it before? Okay, so create. Welcome. Create a cluster map. That's what I'm using now. The data you'll be using since. So import Seaborn as so SNS dot cluster map work data method word command CMap. There are some attributes we have already known. CMap is one that will control the color. R E E U. Shift just to define the size. Big size equals to, let's say 8 by 6. You have error. ST label equals to data dot column. Let me see. So now let's see the shoe. All right, so think you interpret it. Don't worry, you will interpret it. We will interpret. Let's go. We have not covered. You know what the essence? It's not making. Oh, don't worry, it will make sense now. Let's go back to because the values are much here. Now, look at the interpretation here. Let me, before we bring the class to end. Now, you can see based on the values in this current data, the values are very small value. So these are the rows. Now, what we are seeing here is a cluster 1. But this is book. Remember that this data is different from that one. So, and you have to interpret it from the top. So, if we have to go through the interpretation, let me allow you to go and work on that interpretation. Look at this idea. Use this idea. You see this red that you are seeing? It means 4. It means 4. Yeah, as in that particular cluster. Yes, by ranking. Look at the diagram here. Say from the top. You start from the top. You read from the top. So, and as we continue, you will see this is cluster typically what? Student.
So it's going to like box it at the end of the day, something like this. So it's either you use the heat map or you use what? The dendrogram. That's why you have both of them stacking. So these are different clusters you are seeing here. Now, if you check here now, you can see that this color is darker compared to what? Having this color here. To tell you that what? To specify another cluster. Now, if you check here now, you have the dark red, but this one is not as dark as this one. So which means that what? There is a drop in here. So here we can say that what? Cluster 1 are students that read what? Books. Cluster 3, typical what? Student that does not read books. Because I said the red means what? Poor. They are not doing well. So if I bring it to this now, anyway, is an option. Remember that we have the other dendrogram. If you don't want to use that word, you can use any one you feel you can easily interpret. So here now, you can see the way I have this now. So if I'm to interpret this now, based on the data set, so I have to go back and understand the data set variable. I think based on the data we are working with, if I have to come back here, before I can do anything in interpretation, I have to go back to where I call that data. Was in that data, right? Let me just call that data. Yes, that is what is designed to do. But since you are learning, and you have to learn all the method, I have to pass the message.